Look around you. Every light bulb, every engine, every city block pulsing with electricity. To us, this feels like immense power. But on a cosmic scale, human civilization is barely a spark. Zoom out. This is one planet. Our entire global energy output is a mere fraction of what hits our atmosphere. Zoom out again. This is one star. The sun radiates more energy in a single second than humanity has consumed in its entire history. Now imagine 100 billion stars. That is the staggering energy scale of the cosmos. And we are just getting started. Despite our sprawling cities and technological marvels, humanity has not even reached the first rung of the Kardashev ladder. In 1973, Carl Sagan calculated our exact position on this cosmic scale. We are currently a Type 0.72 civilization. What does it mean to be Type 0? It means we still extract our primary energy from dead plants, fossil fuels, buried deep underground. We are a fraction of a Type 1 society, far from harnessing the total energy budget of our home planet. In 1964, Soviet astronomer Nikolai Kardashev proposed a revolutionary way to measure a civilization's technological advancement. He realized that true cosmic progress isn't measured in culture or politics, but in raw energy consumption. The scale is defined by a strict mathematical formula. K equals log base 10 of P minus 6 divided by 10. Here, P represents the total power a civilization can harness, measured in watts. Because it's a logarithmic scale, every jump of 1.0 represents a staggering 10 billion-fold increase in energy. The first major milestone on the Kardashev scale is a Type 1 civilization, a species that has achieved total mastery over its home planet. To reach this level, a civilization must harness and utilize every single drop of energy that reaches its world from the parent star. For Earth, this means generating roughly 10 to the 16th power watts of continuous energy. That is orders of magnitude beyond our current capacity. It requires capturing all solar radiation, perfectly managing global wind and ocean tides, and tapping deep into the planet's geothermal core. A true Type 1 society controls the weather, prevents earthquakes, and commands the entire planetary output. When will humanity finally reach Type 1 status? Based on our historical energy consumption trends, physicists estimate we could cross the threshold within the next 100 to 200 years. But this window of time is widely considered the most dangerous phase for any advancing civilization. It is the transition from Type 0 to 1. We have the power to destroy our planet, but not yet the capability to fully control it. Surviving this bottleneck requires critical breakthroughs in fusion energy and a truly global grid. The next monumental leap in the Kardashev scale is the Type 2 civilization. Having completely exhausted the energy resources of their home planet, they must look to the heavens for survival, their ultimate target, the host star. A Type 2 civilization doesn't just live near a star, they engineer it, harnessing its total staggering energy output. To achieve this impossible feat, they construct a megastructure, most commonly theorized by physicists as a Dyson swarm. Imagine millions of independent solar collectors and habitats orbiting the star in a dense, intricately synchronized formation. Slowly, systematically, they encapsulate the sun, capturing every emitted photon to power an empire that spans the entire solar system. When we picture a Type 2 civilization, we often imagine a solid Dyson sphere enclosing a star. But structurally, a rigid shell is physically impossible. Gravitational stress would tear it apart. Instead, the reality is a Dyson swarm, not one object, but trillions of independent solar collectors. Each individual mirror orbits the star in a complex, carefully choreographed, intersecting path. They capture the star's immense radiation and convert it into usable power. Then, through precise lasers or microwave beams, they transmit this energy back to a central planetary hub. This scalable swarm can be built gradually, piece by piece, fundamentally transforming an entire solar system over thousands of years. Welcome to the ultimate tier of the Kardashev framework, the Type 3 civilization. This is where engineering reaches a galactic scale. Having outgrown their home star, this species has expanded across the interstellar void, colonizing billions of neighboring systems. They command the total energy output of an entire galaxy. That is roughly 10 to the 37th power watts of continuous power. Trillions of stars, black holes and nebulas are seamlessly networked together into a vast unified cosmic grid. To a Type 3 civilization, the Milky Way galaxy is just a circuit board. To fuel a truly galactic empire, the light of billions of normal stars simply isn't enough. A Type 3 civilization must tap into the raw, violent power of space-time itself. Their first target: black hole accretion disks, harvesting the immense friction of matter spiraling into the void. Next, they might capture gamma-ray bursts, channeling the most energetic explosions since the Big Bang. Finally, quasar tapping, harnessing active galactic nuclei that outshine entire galaxies. These exotic sources provide the unimaginable power needed to maintain a galaxy-spanning infrastructure. When we look out into the deep cosmos, we expect to see a relatively even distribution of galaxies and glowing stars. But astronomers have discovered massive regions of space that appear almost entirely empty. The most famous is the Buta's Void, spanning an immense distance across. This colossal spherical region contains only a tiny fraction of the galaxies it should. This brings us to a fascinating piece of theoretical speculation. What if this vast void isn't actually empty at all? Imagine if a Type 3 civilization expanded through that region, systematically surrounding billions of stars with energy-harvesting Dyson swarms. Those stars would vanish from visible light, hiding an entire galactic empire behind an invisible veil of infrared waste heat. If the Kardashev scale is accurate, a Type 3 civilization should be visible from across the universe. Their megastructures and energy signatures would light up the cosmos. Yet, when we look out, we see silence. This is the Fermi paradox. If they exist, where is everyone? There are three main possibilities. First, the Great Filter, an evolutionary wall that destroys civilizations before they can expand. Second, the Rare Earth hypothesis. The conditions for intelligent life are simply a cosmic lottery we won. Or third, we are the first. The universe is finally calm enough, and we are the pioneers. Why does this cosmic scale actually matter to us right now? It's not just a thought experiment, it's a roadmap for survival. A civilization restricted to a fraction of its planet's energy is highly vulnerable. We are at the mercy of natural cycles and cosmic threats. Reaching Type 1 is a fundamental survival requirement. It gives us the power to control climate systems, stabilize the biosphere, and deflect incoming asteroids. The bottom layer of the scale is pure survival. Once secured, the middle layer, Type 2, allows for true expansion across the solar system, making extinction nearly impossible. Finally, the top layer, Type 3, represents cosmic transcendence. Mastering this energy ladder is the only way to ensure intelligence outlives its fragile homeworld. If these advanced civilizations exist, how do we actually find them? We look for technosignatures. The fundamental law of thermodynamics dictates that every machine, no matter how advanced, produces waste heat. Even a galactic empire harnessing the power of a billion stars cannot hide from the laws of physics. When a Type 2 or Type 3 civilization encapsulates a star with a Dyson swarm, the visible starlight is blocked. But that absorbed energy must be re-radiated out into space as lower energy infrared light. By scanning the cosmos for this unnatural infrared excess, we are effectively hunting for the heat exhaust of alien engines. To understand our cosmic journey, we must first look at where we stand today on a global scale. Every day we power billions of homes, heavy industries, and vast digital networks across the planet. In total, humanity's current continuous energy consumption hovers around 18 terawatts. It sounds massive, but a true Type 1 civilization requires harnessing Earth's entire energy budget, a staggering 10,000 terawatts. While our energy use is growing exponentially, we still need to increase our total output by over 500 times. This massive gap highlights both our current limitations and the monumental engineering challenge ahead. The transition from Type 0 to Type 1 is the most dangerous hurdle for any civilization. To cross it, we must fundamentally upgrade our planetary infrastructure, starting with Step 1, mastering nuclear fusion. We must replicate the power of the stars here on Earth, providing limitless, clean baseline energy. Step 2, a global smart grid. Energy must flow seamlessly across continents, balancing planetary supply and demand in real time. Step 3, space-based solar power. Capturing the sun's energy above the atmosphere, unaffected by weather or night. But ultimately, reaching Type 1 isn't just about physics. It requires a fractured world uniting as a single global civilization. We stand at the precipice of our own evolution. Looking back, we see a fragile civilization bound to a single planet. Looking forward, we see the staggering potential of cosmic mastery. The Kardashev scale is not just a measure of energy, it is the ultimate measure of survival. The universe is silent, waiting. Will we be the first to climb the ladder? Or just another ghost in the cosmic void? From our humble beginnings burning fossil fuels, to the dream of harnessing the entire Milky Way, the Kardashev scale isn't just a measure of energy, it is a roadmap for the evolution of intelligence itself. As we look up at the night sky, we are no longer just observing the stars, we are looking at our potential future.